Hi guys, Mr. Antonucci here, and in this video we're going to do a nice comprehensive review of some multiple choice and free response questions for Unit 7 on differential equations. Now, my advice to you for how to use this video is when you see the question come up, pause the video, work it out yourself, and then resume playing the video and check your work. Feel free to rewind it, go back as many times as you need to review each question so that you understand how it works. So let's jump in. So the slope field for a certain differential equation is shown above. Which of the following could be a specific solution to that differential equation? So if we look at these different equations here, what we have to do is see which one follows the general pattern of the slope field. So if you look at the first equation, y equals x squared, that's going to have a parabolic shape, upward opening, which that doesn't follow the pattern in the slope field. One thing you can do in the slope field, however, is pick a point on a tick mark and then draw a curve that passes through the tick marks around it and is parallel to those ones. What I mean by that is if I'm going to sketch the curve, it's going to go like this. That's definitely not x squared. E to the x, that has that exponential concave upward increasing, so it's not that one. E to the negative x is just the exponential function reflected across the y-axis, so it's going to look like this. Still not what we're looking for. Cosine is going to have that periodic nature. Still not what we're looking for, but natural log does have that increasing concave down type of shape. So for this one, that's what we want. Choice E, natural log. So another slope field problem, which of the following is a slope field for the differential equation dy dx equals x over y? So with these, what you want to do is pick strategic values or quadrants for x and y and see which slope field lines up. So what I mean by that is along the line x equals 0, that's the numerator of the slope. That means the slope's going to be 0 along the line x equals 0. So the line x equals 0 is a vertical line going through the origin. Well, if you look at this graph, that vertical line going through the origin does not have horizontal tick marks. So they're not slopes are not 0 there. So it's not that one. If you look at choice B, similar thing. Not going to be that one. If you look at choice C, D, and E, they all have slopes of 0 along the line x equals 0. So those three are candidates so far. Also, if y equals 0, that makes the denominator 0, which makes the slope undefined. So if the slope's undefined along the line y equals 0, that's going to be along the horizontal axis. Now, that doesn't really help very much because none of those are showing that. So what else can we do? Well, we know that the slope is going to be 1 when x equals y. So if we look along the line x equals y or y equals x, we should have slopes of 1. That would be along this line right here, this line right here, this line right here. Only choice E has slopes along that line that are equal to 1. So that's most likely our answer, and in fact, it is. We can also look at the slopes are going to be equal to -1 when y equals the opposite of x. So if x and y are opposites, then x over y is going to be equal to -1. So if we look to just verify this line, y equals -x, has slopes of -1. So that further confirms what we want. Also, you can look like in quadrant 1, x and y are both greater than 0. So no matter what you do, x divided by y, the slope's going to be positive. So in all of quadrant 1, the slopes are positive. And you can go around the different quadrants and see the signs. For example, quadrant 2 is going to have all negative slopes because x is negative and y is positive, so when you divide them, you always get a negative. At the end of the day here, our selection would be choice E. So which of the following is a solution to the differential equation dy dx equals 4x over y, where y of 2 equals -2? So this is a classic separation of variables problem. So what we're going to do is multiply the y to the left side and the dx to the right side. So you would have y dy equals 4x dx. Then you integrate both sides. And the left side is going to be 1/2 y squared. The right side is going to be 2x squared plus c. And then you solve the equation for y. First multiply by 2. So 4x squared. I don't like to write 2 times capital C. I just keep that as C because C represents a constant and 2 times a constant is still a constant. And then that's going to be squared. So take the square root. Now you have to be careful here. Remember, when you solve an equation and you take the square root, you have to account for the fact that the equation could have been positive or negative. And then that's where this initial condition comes in. That helps us determine whether we want the positive or the negative. So you substitute that in. -2 equals plus or minus the square root of 4 times 2 squared plus c. So -2 equals plus or minus the square root of 16 plus c. Now, to get the left side to equal 2, the right side has to be the negative root. So this is -2 equals negative root 16 plus c. Square both sides, you have 4 equals 16 plus c. Subtract, and you'd have c equals -12. So our particular solution would be y equals negative root 4x squared minus 12, which is choice C in this case. And they restricted the domain to be greater than root 3 because anything less than root 3 is going to give you a negative under the radical. dy dx equals y times secant squared x, and y equals 5 when x is 0, then y equals, here's another separable differential equation problem. So we want to separate the variables. This time you would have dy over y equals secant squared x dx. And we want to integrate both sides. The left side's going to be natural log absolute value of y. Don't forget the absolute values. The other side's going to be tangent x plus c. All of these are solved for y, and that's implied when they say then y equals. So we have to solve for y. Exponentiate both sides. Up here we would have absolute value of y equals e to the tangent x plus c. Now we need to take care of those absolute values. If you take them off, that means the y could have been positive or negative. So this is another situation where you want to account for the plus or minus. And then we can substitute in our initial condition. So that's essentially the point 0, 5. So 5 equals plus or minus e to the tangent of 0 plus c. Tangent of 0 is 0, so this would simplify to 5 equals plus or minus e to the c. Now we know this has to be the positive answer because e is never going to be negative no matter what you put in for c. And then to solve for c, we can natural log both sides. C equals natural log 5. So our particular solution now is going to be y equals e to the tangent x plus natural log 5. And you might be wondering, well, there's no answer there that's like that. Here's the thing. If you remember from algebra, if you have a to the x plus y, properties of exponents, you can write that as a to the x times a to the y. And that's exactly what we're going to do here with the addition in the exponent. So this is going to be e to the tangent x times e to the natural log 5. That e and natural log 5 are going to cancel, making 5 the coefficient of the e to the tangent x. That makes our final answer choice C. So here's another slope field question. Shown above is a slope field for which of the following differential equations? Well, in this case, we need to match which differential equation lines up with this slope field. Again, I'm going to pick strategic values that make the slope positive or negative or undefined or 0. So if I look at choice A, if I let y equal 2, that's going to result in a slope equal to 0. Well, if I look along the line y equals 2, there are slopes equal to 0 along that line. So this is a candidate But the problem is also along the line y equals -2 are slopes of 0. There's no way -2 for a y value is going to make this differential equation in choice A equal to 0. So we can eliminate that one. For problem B, if y equals plus or minus 2, then the slope is equal to 0. That definitely lines up. Also, if y is greater than 2, then the slope is going to be positive for this one, since y squared minus 4 is in the numerator. Notice for values greater than 2, the slopes are positive. Also, if y is less than -2, the slopes are going to be positive. So for down here, the slopes are positive. And if y is between 2 and -2, that's going to make the numerator up here less than 0, which makes the slopes negative. And if you look between the y values 2 and -2, all the slopes are negative. So the choice is B. Now we can eliminate C and D really quickly by showing that if x equals 2, does that result in a slope of 0? Well, if x is 2, that would be along this line right here. And you can see that the slopes vary. And similarly for choice D, that would be x is plus or minus 2 is going to make the slope 0. And we already eliminated plus 2, so that's not going to work either. So our choice is B. So here we have a free response question. So we have the differential equation y minus 1 over x squared, where x is not equal to 0. We have to sketch the slope field here. They may do this on the AP exam. They're only going to give a limited number of points. You're not going to have to sketch a giant slope field. Here, it's only 9 points. I'm going to look at the different points. So -1, 0, and then dy dx. So at -1, 0, you would have a slope of -1. All I'm doing is plugging the x and y values into here. So that's going to be a slope about that. So -1, 1 is going to have a slope of 0. And then -1, 2 is going to have a slope of 1. Then we move to the next vertical column, 1, 0. That's going to have a slope of -1. Then 1, 1. That's going to result in a slope of 0 also. And then 1, 2. That's going to result in a slope of 1. So these two vertical columns should look identical to one another. Then we're going to do the last vertical column, 2, 0. That slope is going to be -1/4. So it's going to be negative, but it can't be as steep as the other two because the slope is -1/4. And then if we plug in 2, 1, we'll get a slope of 0. And if we plug in 2, 2, we'll get a slope of +1/4, which again should have a positive slope to it, but shouldn't be as steep as the other ones. And that's kind of what they're looking for when they're grading this. Also, we need to find the particular solution to this differential equation with the initial condition f of 2 equals 0. This notation here implies that you're going to solve the separable differential equation all the way to y. So first thing we're going to do is separate. So you would have dy over y minus 1 equals dx over x squared. Integrate both sides. So this would be natural log absolute value of y minus 1 equals -1 over x plus c. Exponentiate both sides. And then you'd have absolute value of y minus 1 equals e to the -1 over x plus c. And I'm going to take off the absolute values. That means the right side could be plus or minus. And then add 1. So y equals 1 plus or minus e to the -1 over x plus c. This is where I'm going to substitute my initial condition, which is essentially the point 2, 0. 0 equals 1 plus or minus e to the -1 over 2 plus c. So -1 equals plus or minus e to the -1/2 plus c. The only way this is going to work is if the exponent on the e is equal to 0. The only way that's going to happen is if c is positive 1/2. And the plus or minus we're going to have as a negative. In this case, the c is going to equal 1/2. So our particular solution for part B is going to be y equals 1 minus e to the negative 1 over x plus 1/2. And that's it. Then for part C, going to do this right here. We take the limit as x approaches infinity of, as x approaches infinity here, this approaches 0 in the exponent. So you just have e to the 1/2. So it's 1 minus e to the 1/2. Or you could rewrite that as 1 minus square root e. Either way is fine. And that's it. So here we have our first BC topic, which is logistic differential equations. However, most of this problem we can kind of figure out even with AB knowledge. So consider the logistic differential equation. Let y equal f of t be the particular solution to the differential equation with f of 0 equals 8. The slope field for the differential equation is given below. Sketch possible solution curves through the point 3, 2 and 0, 8. So if we have 0, 8 here, remember to draw the solution curve, you want to follow the direction of the tick mark and make your curve go parallel to the tick marks around it. So it's going to come down and pretty quickly level off here. Okay, this horizontal line of tick marks of slope 0 means it's going to level off there. It's a horizontal asymptote. And that's the point 0, 8. At 3, 2, which is right here, you want to follow parallel, and then it's going to increase and start concave down and then level off. But then we have to go the other direction, and it's going to be concave up, but also level off at the t-axis. Part B, however, is definitely BC only topic. Using Euler's method, start at t equals 0 with 2 steps of equal size to approximate f of 1. Our y1 value is going to be equal to our initial y value. So at t equals 0, we know that we're using the y value of 8. So remember, Euler's method is you take your starting y value plus the slope at that starting point times your increment, which is delta x. In this case, if we're doing 2 step sizes of equal size to approximate f of 1, we're essentially starting at t equals 0, taking 2 steps to get to t equals 1. So 2 steps, 1 unit, each step has to be half a unit. So this would be 8 plus the differential equation evaluated at the point 0, 8. So that's going to be 8 over 8 times 6 minus 8 times our increment, which is 0.5. So this would be 8 plus negative 2 times 1/2, which is minus 1. So you have 7. That 7 becomes the y value for your next step. So this would be 7 plus the slope evaluated at the new point's value. So that's going to be 7/8 times 6 minus 7 times our increment, which is 0.5. So 7 plus 7/8 times negative 1 times 0.5. That's going to be 7 minus 7/16, which is equal to 6 and 9/16, or 105 over 16. Either way is fine. That's part B. Part C, what is the range of f for t greater than 0? So a couple things. T has to be greater than 0. So if we look at the graph of f, so f is the solution curve that goes through 0, 8. So that's this one. And it starts at t equals 0 and goes positive. So we only want the range for t greater than or equal to 0. Well, if you look at that, it starts at 8, decreases in a concave up manner, and levels off at 6. So our range would be y less than or equal to 8 and greater than 6. All right, guys, that's it for our review of multiple choice and free response questions for Unit 7 on differential equations. Hope that was helpful to you, and good luck.